In the previous record, we analyzed the linear and the quadratic function, which are a special case of the more general class of polynomial functions. Polynomial functions are also a special case of an even large class of functions, the rational functions. In this section, we will describe the basic properties of the graph of polynomial and the rational function, and so on. We will discuss the graph. We will use this function to solve the real world problems where linear or quadratic model are inadequate. For example, to determine the relationship between the length and the weight of species of fish, or to model the training of the new employees, etc. Okay, let's start from the polynomial function. Polynomial. A linear function has the form f of x equals mx plus b. Here, m is different than 0, and which is a polynomial function of degree 1. Why? Because the power of the x is 1. Here it is not written, but we have a power of the 1. Power of the x is a 1. And a quadratic function has the following form: ax squared plus bx plus c. Here a is different than 0. This quadratic function is a polynomial function of degree 2. Why? Because the power of the x, the highest power of the x, is 2. Here is the general definition of the polynomial function. Now I will give the general definition of the polynomial function. A polynomial function is a function. Okay, let's write as a definition. A polynomial function is a function that can be written as the following form: a sub n x to power n plus a sub n minus 1 x to power n minus 1 plus blah 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 plus a1x plus a0 for the some integer n. Here the integer n is called the degree of the polynomial, but of course we assume that an is different than 0. Okay, here let's emphasize a0, a1, a2, blah 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 an are all real numbers, okay, which are called the coefficients. These are coefficients. And the domain of the all polynomial functions is the set of all real number. Okay, so here this is a polynomial degree, and this n is the degree. Let's emphasize the highest power of the n is the degree of the polynomial. So you are familiar with some of the polynomial as we mentioned here, linear and the quadratic case, and you know the graph of this function and these functions. So in general, we can give some example for the graph of the polynomials, but of course you will be able to sketch these graphs. For example, if this is linear again, this is the linear function. So for example, this is 2, this is 2. So this function is f of x equals x minus 2 graph. Okay, this is a polynomial graph. another graph of the polynomial function. Let's show that this one. I'm using some example from your textbook. Okay, this is the polynomial function. Whoop, what happened? Interestingly, it is vanished. Okay, I lost this data. Let's sketch again quickly. F of x equals x minus 2. And another example. G of x equals x cubed minus 2x. Actually, it's symmetric, but here it is not seen. Anyway, almost is correct. We can give the several examples without writing the function. This is also graph of the some polynomials. Okay. We will discuss all details, and also the square function. This is also polynomial, and you can find some more examples in your textbook. But we should notice something. Maybe on the real example you can sense this fact. So let's give some real example. Okay, you cannot, you will not. You are not able to sketch the following graphs, but from the textbook you can find, or by using some math tools you can sketch that graph. Okay, so the graph of the x to power 5, this one, like this one, by looking at the graph I'm sketching. H of x equals x to power 5 minus 5x to power 3 plus 4x plus 1. Another example, let's write some odd degree polynomial. These even degree polynomials, sorry, all of them are the odd degree now. So that is okay. This is the let's say key of x equals x to power 6 minus 7 to x to power 4 plus 14x square minus x minus 5. Okay, so this is another example. So from this graph you can notice that the odd degree polynomial graph starts negative. Starts negative part. Why is negative here? So y is negative, y is positive. So which starts negative part? Again, this starts negative part. This part is the positive part for the y. Okay, so on the left side of the graph starts negative part of all degree polynomial. If you have a minus x to power 5, okay, it can be different. So if the coefficient of the highest degree term is positive, always which starts the negative part. For the even degree polynomial, graph starts the positive part. Okay, here this is the y, so y is positive, here y is negative, so graph starts from the positive part. And what can we say? The coefficient of the highest degree term is called leading coefficient. Okay. Here all of them are 1, but let's consider some example. For the f of x equals 3x to power 4 plus 4x cubed minus 2x minus 1, for example. Here 3 is the leading coefficient. It is called a leading coefficient. Okay. For the positive case of the leading coefficient, we talk about the these graphs. If any leading coefficient had been chosen negative, then we would have a similar graph but reflecting the x-axis. So for odd degree polynomial, which starts from the positive infinity, and for the even degree polynomial, that starts from the negative infinity if leading coefficient negative. A polynomial of degree n can have at most n linear factors. At most, okay, not have to be. At most n linear factors. Sometimes it can be less than n. So I don't know here, but in general, an x to power m plus an minus 1x to power m minus 1 plus blah 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 a2x squared plus a1x plus a0 can be written as the following for with the n at most n linear factor. So x, for example, of course we have an x minus bn, let's say, times x minus bn minus 1 times x minus, or not minus, plus, okay, plus is okay, bn minus 2 blah 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 times x plus b1. So we have n factor, so we don't need the b0, okay. So here at most n linear factor, n linear factors, but at most. Therefore, the graph of a polynomial function of the positive degree n can intersect the x-axis at most n times. It can be less than n. Okay, so here, if the degree is 5 and the starts from negative, an is positive, we intersect the x-axis 1 times, 2 times, 3 times, 4 times, and 5 times. Okay, so this is degree, the graph of this function, at most 5, maybe less than 5, okay? But degree of the f of x is bigger and equal 5. It can be 6, 7, etc. But at least 5, because any polynomial with the degree n has at most n linear factor. These x-intercept, these are is also called a zero or root of the function, okay? These are root of the function. So x1, x2, x3, x4, x5 are the solution of the f of x equals 0. So x1, x2, blah blah blah, x5 are zeros of the function f of x, or roots of the function f of x. The graph of a polynomial function is continuous. What that means? There is no hole or breaks, or in other words, the graph can be drawn without removing a pen from the paper. So without raising your hands, you can sketch the graph, okay? In the future, we will discuss the continuity again after learning the limit concept. Also, the graph of a polynomial has no sharp corner. What that means? There is no sharp corner. Okay, again, without raising our hand, we sketch this graph, but there is a sharp corner. So it is not a polynomial. It is not a graph of any polynomial. Okay. And breaks, no breaks. So, for example, there is no break like that one. For example, this is the graph, and here it continues. This is not a polynomial again, okay? Not polynomial.